Okay, hello everyone. Today our topic is about electricity 5, and we were just talking about the last part of electricity. Okay, so let's move to the first slide, a review of the series and parallel resistors. Okay, so let's move to the first slide. And here we can find there's a circuit, and we have a 12 voltage battery and four 6 ohm resistors. Okay, so right here, you can find they're just combined in series or like they're just combined in parallels, right? So maybe you can using them just to consider them as a one resistance and just solve the problem. Okay. So maybe here let's just have a quick review for like here if the resistors are combined in series. And here maybe we have two resistors, one is R1, another is R2. And we can say the total resistance here is R1 plus R2. Okay, this is total resistance. Okay, so this is for like here, the total R equals to R1 plus R2. And maybe you can set for the resistors here, you can just consider it as one resistor. And there's 3 ohm and here 6 ohm. Total resistor here is 3 ohm plus 6 ohm equals to 9 ohm. So we can set, oh, the formula R equals to R1 plus R2. Okay, this is for the first situation. And if we just combine the resistors in parallel, we can find there's a 3 ohm resistor, 6 ohm resistor, and there you can just using the formula that for total resistance, like 1 over total resistance equals to 1 over 3 plus 1 over 6. And here you can find the result is 1 over 2. That means the resistance here equals to 2 ohm. Okay, this is for the resistors. Okay. Okay, so let's move into this exercise. Like here, we can just trying to like discussing about different kinds of resistors. So you can just regard it A and B as just one single resistance, right? Like here they are both 6, so they are connected into series. So for the total resistance here is R1 or RAB equals to RA plus RB, right? Using that formula equals to 12 ohm, okay? That is for AB's total resistance, or you can just regard them as this resistance and resistor is 12 ohm right here, okay? And if you just consider ABC into one resistors, okay, so you can just say, oh, because AB can regard it as one resistor that resistance is 12, right? So you can say, oh, for RABC, you can use the formula 1 over RABC equals to 1 over RAB plus 1 over RC, right? And that here is 1 over 12 plus 1 over 6. And here it is 1 over 4. So for RABC, total resistance here is 4 ohm. Okay, this is for this resistance. Okay, and if you just combine or like A, B, C, D together, and here you can find if you just consider here ABC as one resistor. So we can draw the ABC graph like here. Maybe we can just hide ABC and just make them a one resistor, okay? So maybe here take a little bit of time, okay? Okay, sometimes I use Google Notes and it will take a lot of time for me to redraw a new graph, okay? Okay, so here, maybe we can say, oh, just consider as one resistor, right? And this is RABC, and this is 4 ohm, right? So if we're just regarding A, B, C, D as total resistors, right? So you can use that because they are combined in series. So R, A, B, C, D equals to 4 ohm plus 6 ohm, right? That is 10 ohm. Okay, this is for R, A, B, C, D. Okay, so you can find here the first exercise is find the total resistance or combined resistance of R, A, and B. So here is 12 ohm, right? For ABC, that is 1 over 12 plus 1 over 6 equals 1 over 4. Total resistance for ABC is 4. And total resistance for ABCD, that is 4 plus 6 equals to 10, right? So here is a result. Okay, I guess it's not very difficult, right? If you're just very familiar with the formula, I guess it's very simple and just putting them into the formula, okay? So here we can find there's a little bit of review for the basic circuit involved. And before the lesson, we have just learned about if the resistors combined in series because they are in the same current, right? So if here you can find there's 2 ampere current and 3 ohm resistor and here 6 ohm resistor, and we can using the ohms law, right? Because ohms law is U equals to I times R. So here for 3 ohm resistor, that is 2 ampere times 3 ohm, that is 6 voltage, right? And for a 6 ohm resistor, that is 2 ampere times 6 ohm equals to 12 voltage. Okay, so you can say that the total voltage here, or potential difference here is 6 voltage plus 12 voltage equals to 18 voltage. Okay, so not very difficult. So we can say that for resistors combined in series, that they just divided the potential difference, right? And they're in the same current. Okay, So this is for the basic review for resistor combined in the series. Okay. So if you combine in parallel, also not very difficult. That here you can say, oh, because it's like a stream that like the total stream is 9 ampere here. So you can divide it into two streams. One stream is 6 ampere and another stream is 3 ampere. Okay. So using Ohm's law, you can find if here we add with a 3 ohm resistor, the total voltage here is 18 voltage, that is 6 ampere times 3 ohm, right? Using Ohm's law. Okay. And also for the resistor below, here using the formula 3 ampere times 6 ohm, it is 18 voltage. The potential difference here equals to 18. Okay. So we can you can find the 3 ohm resistor and 6 ohm resistor, they both have a 18 voltage potential difference. So they have the same potential difference. They just divide it, or they just divide the current into two parts, right? Okay, this is for the basic circuit rules right here. Okay. Okay. And after that, let's maybe have a little bit of review for the electrical power equation. And here you can find there's an equation that is power equals to potential difference times current. So you can use the formula that is power equals to U times I, right? And here that is for the power, okay. So maybe we have a brief review for power. And I remember when we talked about for the forces and power and work done, right, at that part. And we said power is unit is watt, right? And here for the U, the voltage, the unit is voltage, right? And for I, the unit is ampere, okay. So we can say, oh, for power equals to U times I, or watt equals to the voltage times ampere, okay. So this is the formula. And if we're using the energy, and we said that because the formula work done equals to power times time taken, right? So also we can say, oh, the energy here equals to the U times I, that is power, and then times the time taken T, okay? That is for the energy consumed in the total equation, okay? So let's move into this part. Like, first question is the current in the battery, okay? So we have said before, like we can regard it A, B, C, D, the four resistors combined together, right? And the total resistance is like 6,666. And this resistance is 4 ohm added with 6 ohm, that is 10 ohm, right? And we can say, oh, the current is using the Ohm's law, that is like I equals to U over R. So it is 12 voltage over like the 4 ohm equals to 3 ampere. This is for the first current. And for the second current, we can say the energy transferred from the battery to the circuit in 50 seconds, right? And maybe here you can use the formula that is the energy or the power, sorry, the work done equals to the UIT, right? The U here means potential difference for the battery, that is 12 voltage, right? So we can put it into the formula, 12 voltage. And the current here is 3 ampere. And for time taken is 50 seconds, so we can just put them inside the formula. And the final answer here is 12 voltage times 3 ampere times 50 seconds. That the final result is maybe here, like, let me guess, it's about 600 and 1,800 joule, right? This is the final answer, okay? So this is a very basic and very classic examples for the circuit. So just try to take a note of this and just try to resynchronize the problem, please, okay? So this is for our today's lesson. So see you next time. Bye.